This video is to give you some useful tips on how to make sign charts in the most efficient fashion. And I'm going to start with example 1. I want to make a sign chart for f of x, and f of x is the given function. Notice that it is in the form of a single fraction. So it's all nicely written, it's a quotient, and everything is nicely factored. If it's not factored, I should do that. And if it's in the example 2, it is the sum or difference of fractions, you would have to write your fraction as a single fraction. But example 1 is all ready to go. Now, when you start making a sign chart, you mark on all the points for which the function you want to make a sign chart for is 0 or doesn't exist. So let's have a little look. Where are my zeros? X is the number line. I'm going to mark on the number line. Let's see, I've got -4. That f of x is 0 there. I've got 3. It's 0 there. It's 0 at -7, but it's actually a little bit more interesting. That radical sign means that x plus 7 must be bigger than or equal to 0. X must be bigger or equal to -7. So actually, the domain of my function starts at -7, and I'm going to cross off everything to the left of it to remind me there's actually no output for the function to the left of -7. Now, if I look at the denominator, x equals 8, the function doesn't exist. Ditto at 1, there's a DNE. So I now have, count them, 1, 2, 3, 4, 5 subintervals that I've got to figure out whether the function's positive or negative. And in the past, I think you have just plugged in numbers in each interval, figured it out, and written in positive or negative. We're going to put f of x here above, and so these numbers above, the number line along here refer to f of x values. So the way I'm going to show you to do a sign chart is to pick one number to the right of 8. So let's say, shall we consider x equals, say, 10. All right, and we plug it in. And as we do that, we can go through, when x is 10, this is positive, that's positive, that's positive, that's positive, everything is positive, and therefore we know the product and quotient of positive quantities is going to be positive. Now, instead of then plugging in a number between 3 and 8, what I'm going to do is to consider what happens to these factors as I were to change a little bit to the right of 8 and then a little to the left of 8, and see which factors would actually change sign. Right now we knew all factors are positive. Is there going to be a change in sign? So let's look at each factor in turn. Let's look at x plus 4, the inside of this factor. Does it make any difference if x is 8 and a bit or 7.9-ish? No, it is still going to be positive, and positive cubed is positive, so no change. How about here? Does it matter whether I'm a little bigger than 8 or a little smaller than 8? No, inside's positive, so fifth power is positive. Ditto for this factor. Now we come to the factor that might change sign. Let's look at that, x minus 8. The inside when x is, say, 8.1 is positive. The inside, though, is negative when you're like 7.9, a little bit less than 8. But because, so the inside will change sign, but everything is being squared. So it doesn't matter if the inside is positive or negative. There'll be no change of sign as I take x values to the right or to the left of 8. And these absolute value factor doesn't change sign. So the only factor that's could change sign is the green factor, and it doesn't change sign because it is being squared. So there is no change of sign for me, and so I'm still positive. In a similar fashion, I'm going to look at what happens a little to the right and left of 3, right? The inside of this factor doesn't change if I'm to the right or left of 3. Whoops, didn't mean to do that. This factor doesn't change. Doesn't matter if x is a bit bigger or smaller than 3. The inside of this factor doesn't change. It's still negative, a negative squared. So it doesn't matter if I'm a bit bigger than 3 or smaller than 3. This factor doesn't change. Actually, its absolute value, so it'll always be positive or 0 anyway. So the only factor that could change is going to be the x minus 3 squared. Let's have a quick look at that one. And what do we find? Yes, the inside does matter if I'm a bit bigger than 3 or smaller than 3. So it will change sign, and it's to the 5th power. So if it's positive, it would be positive. If it's negative, it would be negative. And so there will be a change of sign at x is 3. Let's just clarify that. When x is 3.1, the inside's positive. Positive to the 5th is positive. But when x is like 2.9, it's negative, and negative to the 5th is negative. So depending on whether I'm to the right or the left of 3, that this factor will change sign. Everything else changes the same, so everything else stays the same, but there will be an overall change of sign. So it was positive, it becomes negative. Similarly, when we look at what happens at x equals 1, will there be a change of sign at x equals 1? The only factor that could possibly be affected is going to be this factor, and you know what? This factor is always positive or 0, and that when x is 1, we know that's DNE, and so when x is not 1, that one is always going to be positive, so there's no change of sign. So if overall f of x was negative, it will remain negative. Okay, let's have a look at the factor x is negative 4. At the 0, x is negative 4. The only factor that could possibly be affected here for a change of sign would be this factor. The inside would change sign, and it's cubed, therefore there would be an overall change of sign. Therefore we are going to go, we were negative, we're going to be positive. So it's much quicker to just look and ask yourself at each of the numbers that you've marked on the number line, look at the corresponding factor and go, will this change sign? And then it becomes a much quicker process. Let's have a very quick look at example 2. Example 2, I don't have a single fraction, so I've got to write it with a common denominator. Common denominator is x times x minus 7. So this I multiply by x minus 7. This I multiply by top and bottom by x. So this becomes 3x minus 21 plus 4x over x times x minus 7, which is 7x minus 21, x times x minus 7. Remember, we want to factor as much as possible, so that's 7 times x minus 3 times x minus 7. Okay, I've now got my fraction as a my sum of two fractions as a single fraction, and I want to mark off the x values in my number line, where f of x is 0, it doesn't exist. It is 0 at 3, 0 at 7 and, oh sorry, it is dne at 7, duh, and dne at x equals 0. So above the number line, I'm writing down what's true about f of x. On the number line, I'm writing in x values. I'm going to start off to the rightmost interval, plug in 8, for example. All my three factors, well, 7 is always positive, x minus 3 is positive, that factor is positive, this factor is positive, when x is 8, everything is positive, therefore let's write in a positive. And then I look at each factor and I ask whether it changes sign. By now you'll have figured out that the inside will change sign, so you look to see what the power is. So let's see if I can, whoops. Let's just see what I'm doing. X minus 3, x minus 7, and x. So the only factor that can possibly change as I go to the right and then to the left of 7 is this factor. And yes, it will change sign, and its power is 1. There will be a sign change. In fact, if you look, the power is always 1 on these. So there will be a sign change each time. There are no squared factors and no even powers, no absolute values, radicals. So that one is pretty easy. The next one is actually kind of interesting. It's if you use a sign chart to solve an inequality, remember what it does is tell you when an expression is positive or negative, right? I'm writing in positive negatives. So it won't tell you if something is bigger than 4 or less than -3. So if you want to solve an inequality, one sign must be in the form of everything else on one side and then less than or greater than or whatever, 0. Must be 0 on one side. So that if I have something like example 3, I don't have a 0. My sign chart for the left-hand side is worthless. It'll only tell me about x minus 6 times x plus 5, whether that's positive or negative. It won't tell me if it's less than or greater than 60. So, think time. What could you do? Yes, you're right. I'm going to rewrite it so that I do have 0 on one side. Okay, then the next step would be to FOIL and simplify, so you then have some other function that is less than or equal to 0. Okay, so whatever it is you end up with, all right, whatever you get, that's what you make your sign chart for. This problem is one of the problems on the homework.